8. So chromatography is used to separate a mixture of liquids and also to identify what they were. Now in chromatography you have two main phases. You have a stationary phase, something that does not move. So basically the piece of paper is going to be your stationary phase, the chromatography paper. And then you have a mobile phase, which is the solvent that they're going to be dissolved in. Usually it's done inside the beaker, and you put a watch glass to prevent water from the solvent evaporating. Now, chromatography is all based about solubility. So what you're going to do is, we've done this already in topic 1. So you're going to get your chromatography paper, draw a line with pencil, put your sample of inks on that pencil line, fill up with solvent just below the pencil line. And then finally, what's going to happen is over time, you'll see that those inks are going to kind of separate in that paper. Now, you'll notice that some inks move much higher than other ones. And the reason behind that is because the ones that move higher, they are more soluble in the solvent. So they are more attracted to the solvent than to the paper. So as the solvent moves up, they're going to be like, yeah, we're going to come with you as well. So they're basically going to go move up. But some of the spots do not move as high. And the reason behind that is because they prefer the paper more than the solvent. So as the solvent kind of moves up and says, come with me, they're like, no, we prefer the paper. Okay, so the reason they separate is based on their solubility. An RF value is used to identify the spot. So the way you do that is, let's say for this spot over here, we want to find the RF value. What you're going to do is the following. Step 1, of course, once this whole process is over, you'll see that the solvent has moved all the way up to here. So you're going to, if you want to find the RF value for this spot, you're going to first put a dot right in the middle, then calculate the distance from the baseline. So let's say that was 5 centimeters. Then you're going to calculate the distance from the solvent to the baseline. Let's say that was 10 centimeters. And then finally, you're going to do 5 over 10. And that will give you the RF value. So let's say that's 0.5. And then with this, you go to something called data books. Okay, or they'll give you some information, and then you can use that to identify exactly what this was.
Hey guys, if that video helped you, support our channel by liking, subscribing, and sharing it with your friends. And more importantly, if you still have questions, drop a post on our forum at ExamQA.com, where I will personally be there to help answer your questions. Mohammed signing out.